In this video, we're going to look at our second type of oligopoly, one where we have Bertrand competition. So with Bertrand competition, now we're going to really see the strategic behavior by firms. In collusion, we saw it a bit in that firms would cheat if they're able to in order to increase their profits, right? For Bertrand, the firms in the oligopoly are not cooperating at all. Instead, they are competing directly with each other. And what makes this model unique is that the firms are going to compete by choosing their price. So they're going to compete on price, on the price margin, rather than choosing the amount that they produce, like we saw with the cartel. For Bertrand, we're assuming that firms make identical products, that they, of course, compete by choosing the price that they sell those products at. And lastly, we're going to assume that they set these prices simultaneously. All right. So when we're thinking about Bertrand, it's easiest if we start with just the example of a two-firm oligopoly. So consider two stores that are producing the same good, right? Maybe it's stores, they're both making soccer balls, let's say, right? Identical soccer balls. And that good is identical, and they're going to try to outcompete each other by offering their soccer balls for a lower price, all right? So what we're going to see happen in terms of market dynamics is going to be summarized in the slide, in the table on the slide. So what we'll see is if one firm offers a higher price than the other, the firm that offers the lower price gets all of the consumers, right? So they sell to all of the consumers in a market, and the firm with the higher price sells nothing. What that means, as we'll see, is that firms are going to lower their price in response to each other as much as they can. And that is going to mean that their price ultimately equals their marginal cost, right? So for our Bertrand competition model, an equilibrium condition for us is going to be that their price is going to equal their marginal cost, okay? Let's walk through the dynamics though in the table before we continue with that conclusion. So let's suppose the first store prices their soccer balls below the second. That means that everybody who wants to purchase a soccer ball is going to do so from firm one, and none is going to be purchased from firm two. Okay. If firm two prices their soccer balls at a lower price than firm one, then the reverse happens. Firm two gets all of the sales and no one purchases from firm one, right? Why would they? They can get the same product at a lower price from firm two. What is going to happen is that both firms are going to price at the same level, meaning that they split the market output exactly, right? So they're going to exactly share the number of consumers who are wanting to purchase that good, all right? Now let's focus in on the price equal marginal cost equilibrium outcome. What we're going to end up seeing, as maybe you were starting to wonder, is that because the firms have this tendency through their price competition with each other to push their price down to their marginal costs, as long as we have more than one firm in an Bertrand oligopoly market, we're going to see an outcome that is the same as the perfectly competitive market, right? As long as the firm is not a monopolist, as long as they're competing with at least one other firm, we're going to see prices pushed down to marginal costs, and subsequently output will be the same as what a perfectly competitive firm would make. Let's look at an example. All right, so I'm going to talk through the givens here, and then we're going to work this out in our notebook. So let's consider an industry. It's going to have two firms. They're facing a market demand of price equal to 100 minus market quantity demanded. And that market quantity demanded is going to be the sum of each of their outputs. So what firm 1 makes plus what firm 2 makes gives us market demand. These two firms, we're assuming, make identical products, and they have similar marginal costs. So firm's 1 marginal cost is equal to 20 plus the amount that they produce, and firm 2's marginal cost is equal to 20 plus what they produce. So because we're looking at Bertrand, each firm is going to compete on that price margin, meaning they're going to try to undercut their competitor's price as much as they can. So that's going to lead them to setting their price equal to their marginal costs. Okay, so you can see that in the second point here. They're each going to set their prices equal to their marginal costs, and as a result, we're going to see that both of their prices end up being the same, since they have similar marginal costs, right? And as we'll see, they'll split output, and so those marginal costs end up being identical. All right. So the slide works through the math a little bit for you. We're going to do it together on the notebook. So let me go ahead and share that notebook. Go ahead and scroll down so we have some more space. Let's remind ourselves what our givens are. So our question here is for a Bertrand oligopoly. They are going to be splitting the market output, right, sharing it among themselves. So market output is going to equal Q1 plus Q2, and their market demand curve is going to be price equal to 80 minus quantity, right? Their marginal cost for firm 1 is 20 plus Q sub 1, and for firm 2, it is 20 plus Q sub 2. Okay. I think I might have miswritten that demand curve. It is supposed to be 100, not 80. I apologize for that. Okay. So now we have all of our givens, and we know as well, let's keep a reminder, Bertrand means that price is going to equal marginal cost. Okay. So our first step here is we're going to rewrite our demand equation and substitute the individual outputs for the market output. So we'll have price equal to 100 minus market quantity, which is equal to Q1 plus Q2. Okay. Then we're going to distribute that negative. So we get price is equal to 100 minus Q sub 1, right? So the quantity produced by firm 1 minus the quantity produced by firm 2. Now what we're going to do is follow the underlying outcome of this model, and that is that both firms will set their price equal to their marginal costs. So let's start with firm 1. So for firm 1, we're going to have price equal to their marginal costs. So price we just saw is equal to 100 minus the amount that firm 1 produces minus the amount that firm 2 produces. And we're setting that equal to firm 1's marginal cost, which is 20 plus the amount that firm 1 produces. From here, what we want to do is solve for firm 1's output. Okay, so we're just going to combine like terms. So I'm going to add the amount that firm 1 produces to both sides and subtract 20. That's going to get us 80 minus the quantity that firm 2 produces equal to 2 times the quantity that firm 1 produces. Next, we're going to divide both sides by 2, such that we get 40 minus 1/2 times the quantity that firm 2 produces equal to the quantity that firm 1 produces. This is what is called a response equation. So we can see that firm 1's output is going to depend in part on firm 2's output, right? Because both of them are going to be able to adjust their price by adjusting their own individual output. All right, so that's why we have this response equation in terms of quantity. Next, let's do the same for firm 2. So for firm 2 here, We're going to set price equal to marginal cost. That's going to give us 100 minus quantity sub 1 minus quantity sub 2 equal to 20 plus the amount that firm 2 produces. And we're going to follow the same process. So we're going to solve for quantity 2 now. We're going to add quantity that firm 2 produces to both sides and subtract 20. That gives us 80 minus the amount that firm 1 produces equal to 2 times the amount that firm 2 produces. Lastly, we'll divide both sides by 2. So we get 40 minus 1/2 times the amount that firm 1 makes equal to the amount that firm 2 makes. All right, so now we have the response equations for both firms. We know now that firm 1's output depends on firm 2, and we know that firm 2's output depends on firm 1. What we can do is take this response curve that we found for firm 2, because it's solved for the quantity that firm 2 makes, and substitute it into firm 1's response equation for that value of firm 2's output. And that's going to get us an equation for firm 1's output that only includes its own output. All right, so that'll be clear once I actually make that substitution. So let's go ahead and do that. So substituting for the output of firm 2, we get 40 minus 1/2 times what quantity 2 is equal to, and that is 40 minus 1/2 times quantity 1, and that's going to be equal to Q sub 1. All right. Now we can solve for the amount that firm 1 makes and find a specific value. So first, let's start off by distributing the 1/2 into our parenthetical. So we're going to get 40 minus 1/2 times 40, which is negative 20, plus 1/2 times 1/2, which is 1/4, times quantity sub 1, right? And note that these negatives here cancel out. So we get a positive. And all of that is equal to the quantity that firm 1 makes. Next, we want to subtract 1/4 times quantity 1 from both sides. And then simplify 40 minus 20. So that's going to give us 20 equal to 3/4 times quantity 1. You might be wondering where that 3/4 comes from. If we consider our right-hand side of our equation, this quantity 1 has a 1 modifying it, and that 1 we can rewrite as 4/4. So when we subtract 1/4 times quantity from quantity 1, that's essentially having 4/4 times quantity 1 minus 1/4 times quantity 1, which we can rewrite as 4/4 minus 1/4 times quantity sub 1, which gives us 3/4 times quantity sub 1. Okay, so that's where we get that 3/4 times quantity sub 1. Okay, and our last step here is going to be to multiply both sides by 3/4 in order to isolate Q sub 1. And that's going to give us our amount that firm 1 produces. And thus, we see it is 80/3, right? 28 times 4 is 80, and then that 3 is in the denominator, and so that is the value that firm 1 produces. Next, we want to find what firm 2 produces. So we're going to rewrite firm 2's response curve. That was quantity sub 2 equal to 40 minus 1/2 times quantity sub 1. We're going to substitute for the value of firm 1's output. So we get quantity sub 2 equal to 40 minus 1/2 times 80/3, right? From here, we can just simplify. So 2 goes into itself once, and it goes into 80 40 times. So we're going to get quantity over 2, the quantity produced by firm 2 is going to be equal to 40 minus 40/3. To make this math simpler, we're going to convert our 40/1 into a fraction that has 3 in the denominator. So we're going to multiply it by 3/3. That gets us 120/3 minus 40 over 3. And simplifying, we see that 120 over 3 minus 40 over 3 is equal to 80 over 3. So we can see that firm 1 and firm 2 end up producing the same amount. All right. That means that our overall market output, right, quantity is equal to what firm 1 makes, 80 over 3, plus what firm 2 makes, 80 over 3, which is 160 over 3. Okay. Next, we want to find the price. So the market price, we're going to find by using that demand equation that we were given. So that's price equal to 100 minus market output. Market output we just found is 160 over 3. So we can substitute that in. We have 100 minus 160 over 3. To make the math easier, we're going to convert 100 into a fraction with 3 in the denominator. So we're going to multiply it by 3 over 3. So we get price equal to 300 over 3 minus 160 over 3. That's going to give us a price equal to 140 over 3, which is equal to $46.67. Okay. So there we have our profit maximizing price for each of those firms, the market output, and each of their individual output. Next, what we want to do is find their profits. So profit for our market here, we're going to go ahead and assume that marginal cost is equal to the firm's average total cost when we solve for profit. So market profit is going to equal the profit that firm 1 makes plus the profit that firm 2 makes. So for firm 1, the price that they're facing is 140 over 3. Their marginal cost is 20 plus the quantity they produce. And then we're going to multiply that by the quantity that they're producing. Okay. So what we want to do, everything is in a fraction form with the denominator 3. So let's go ahead and convert that 20 so that it is also in fraction form with a denominator of 3. So to do that, we're going to multiply 20 by 3 over 3. And that's going to give us, then for our equation, 140 over 3 minus 60 over 3 plus 80 over 3 times 80 over 3. Okay. This is going to equal 140 over 3 minus 140 over 3 times 80 over 3. And probably you can already see, right, 140 over 3 minus 140 over 3, that is going to go to 0. 0 times 80 over 3 is 0. So firm 1 earns 0 profit. And we know that this is also going to be what firm 2 earns because their marginal cost is similar to firm 1. It's 20 plus their output, and their output is exactly the same as firm 1. So their average total cost is going to be the same. And then for their price, they're facing the same market price that firm 1 faces because they both set that same price. And so what we're going to see here is that both firms are earning 0 profit. So you can see quite clearly here that this Bertrand market is operating like a perfectly competitive market. Both firms are pricing equal to their marginal costs, meaning that they earn 0 economic profit. That is going to finish up our coverage of the Bertrand competition model. Next, we're going to look at Cournot, and that will be the last oligopoly model that we discuss for this chapter.